part C of 2014, it says, find the time t for which the amount of grass clippings in the bin, so the amount of grass clippings in the bin, right? That's A of t. Is equal to the average amount of grass clippings in the bin from the interval 0 to 30. So the average amount, right? The average amount is how much for this one? Right. So the average amount is equal to 1 over 30, 0 to 30, A of t dt. Okay. And that is equal to, so again, if you go on your calculator, you can go and do like control, add a page, calculator, right? And you can do it here. So basically it'll be 1 over 30 times the integral. And because I have it saved already, 0 to 1, f1 of x, oh, 0 to 30, f1 of x dx. All right, it got deleted. Oh, it came back. You could do control and this one, it's like control Z, it undoes it, yeah. So 3, 0. Okay, and that's that value. So 2.7. So what I'll do here is I'll say this is equal to 2.75264. Okay. Now, the question is asking, when is the amount equal to that? So what you want is A of t equal to 2.75264. All right? Now, there's a couple ways you can do this. One is you can take this and you can't store it that way. All right, let's copy here. And you can store it as A. All right?
Wait, that's so cool. I didn't want to do that.
And then when you come here, you can go to tab and you can press A, enter, and that's that line. Whoa. I know.
It's very efficient.
Mm-hmm.
What did you click to get the arrow? Did you click
Control store, like you see how it says STO?
Oh, so it's the same
Yeah.
when you do it on the scratch.
Yep. Oh, what did it?
Wow.
So A, enter. You really should be doing these with me. So now if you want menu, analyze graph, intersection, that's that point right there. 12.415. All right? Like, you gotta be as slick as you possibly can.
Wow.
There's another symbol you can do.
Yeah. Huh?
If you write your variable and control this, you set hidden value.
Yes, you can do that one as well. I just want to be consistent.
Okay.
The one next to it, the one next to the 9, also.
Oh, dear.
Yeah.
Yeah, that works like the equal sign.
I was taught to do that for the same features.
Yes.
What does that do? It's one to take that.
Okay. So D,
Oh, okay.
what does D want?
The linear approximation.
T is measured in days, so you want to write days here for C. Okay. So for T is greater than 30, the linear approximation is a better model. use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. So you want, L of 0.5 basically. So what we want for D is first
You don't want L.5.
L of t. You want it when it equals to 0.5, yes. So first we want L of t though, okay? So for that, remember we want like mx minus x1, right? So I want the slope first, which is a prime of 30, right? Times t minus 30 plus a of 30. So that's mx minus x1 plus y, right? We just have it in like different notation now. All right. Now, a prime of 30, right? If I haven't found it yet, then I could go into my calculator here and I just do numerical derivative at a point. So tab 30, okay? And I want f1 of x here. All right, and so it's that value. And then you also want a of 30. So you also want f1 of 30. And that's that point. Okay? So a prime of 30 is negative 0.0560. A of 30 is 0.783. And honestly, at this point, you could just say L of 30 because this is the calculator section. You can, so now what you want is, when is L of t equal to 0.5? Right? So now, you could go back here. Okay, again, like there are many, many different ways of doing this one. If I go here, okay, let's put in that function.
You could just solve it analytically, not algebraically if you want.
You could solve it analytically, but it's with all the variable, like with all the decimals and stuff, right? So what you want to do here is in F3, you want to put that equation, right? So it's negative 0.0560 x minus 30 plus 0.783, right? That's that linear approximation. And then you want to see when that equals to 0.5. Okay? So you could do another graph and do 0.5 and see where they intersect, like whatever is comfortable for you. There are many, many different ways of doing this. All right? Okay. The t value is 35.05. That's not enough decimals. 0.54. Okay? But I did try it with my calculator and it does work to do it that way. Yeah. While you're writing that down, let R be the region enclosed by the graph of this chordic function and the horizontal line y equals 4. So presumably this is y equals 4. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. So right over there. Okay, we can do this because we just say that the volume is pi. Okay, and so let's first figure out the big R and the little r. So the big R goes from the outer to the line of rotation. So 4 minus -2, right?
So it's top minus bottom.
So it's 6. So it's the big R squared minus the little r squared. That's from the function down -2. So that's going to be x to the 4 minus 2.3x cubed plus 4 minus 2. Oh, you know what? I didn't even need to write that. I'm sorry. I'm erasing that. I forgot this is the calculator section. All you have to write is f of x minus 2 squared dx. Now, you do have to figure out the point of intersection, though. So let's go here, tab, and you know what I'm going to do is I'm just going to delete all of these.
This one again?
Yeah.
Isn't it minus 2? So
It's positive.
Yeah.
Oh, yeah. Okay, so it is x to the 4 minus 2.3x cubed plus 4.
How do you unstore something?
Just, okay, so let's go to menu and let's go to Windows Zoom, Window settings. I'm going to go from -1 to, hang on, let me do one thing at a time, please. To 4, and then I'm going to do 0 to 5. Okay, that's what that looks like. And then if I do tab again and do 4, right, that's that line. So if I want to do menu, what happened? Analyze graph, intersection. All right, we're going to store this, right? And it's just 2.3. So you don't even have to store it if you don't want to, because it's, you know, small enough. So this is going to go from 0 to 2.3. Okay, and that's a plus. All right. So then all you need is this, and then if you go to your calculator, you're just going to do pi, just plug it in, pi integral from 0 to 2.3. You're pressing tab for these, right? 36 minus f1 of x in parentheses plus 6 squared dx.
Wait, why did you have 1 of x plus 6? It's plus 2. Minus negative.
Oh, wait.
Okay. Okay, so part B.
Oh, yeah. That's 1 of x.
Region R is the base of the solid. Each cross-section perpendicular to the x-axis is an isosceles right triangle. So isosceles right triangle, and then this is the, with a leg in R. So that's the leg in R, right? So that's this. And so how big is that? It's 4 minus f of x, right? Right. So that means the area is how much?
4 minus f of x squared over 2.
Yes. So the area is half times base times height, which means the volume is going to go again from 0 to 2.3, and it's going to be the area times dx, and I could just, you know, pull out the 1/2 here, or you don't have to, it's up to you, and it's going to be 4 minus f of x squared dx. That's how you plug it in your calculator, and it gives you 3.574.
You know that it's nothing involving like the horizontal line anymore.
It's not, it doesn't say that it
Yes,
is.
it doesn't
Yeah.
say.
And plus, if it's an area with cross sections,
Then they can't.
then you're not revolving. The vertical line x equals k divides R into two regions with equal values. So we're going to suppose that this is x equals k. Write but do not solve an equation involving an integral expression whose solution gives the value of k. Okay, there are two different ways you can write this. One is, all right, so the integral from 0 to k, and you want the, so this is equal areas, right? This is equal areas. And what we said was the area of this region is 4 minus f of x dx. All right? Now, no, this is area. It's just y1 minus y2. Now, there are two things you can do. One is you can say this is half of the area from 0 to 2.3, 4 minus f of x dx. That's all you have to write. Or you can say this equals from k to 2.3. It's the same because you're not evaluating it.
Oh, you know that.
It just says to write. So either one will be okay. All right.
Can you say, do you have to have them equal, or do you have k over 0 and that minus the other equals 0?
Yes, you can do that. Okay. Function f is defined on the closed interval -5 to 4. Okay? The graph of f consists of 3 line segments. G is defined by this. So G is the area from -3 to x. And -3 is here, just to get a, point of, reference. Now, we want G of 3 first. G of 3 is -3 to 3, f of t dt. All right, and that's equal to, yeah. So, from, in the triangle on the left, that has an area of 6, this has an area of 1, and we're going in, 4, and we're going until here. That has an area of 1. So that's going to be 6 plus 4 minus 1. Okay? B. On what open intervals from -5 to 4, so the whole thing, is the graph of G both increasing and concave down, right? So G is increasing when G prime is greater than 0, correct? Well, what is G prime? So look at how you can write it. G prime is equal to f of x, and that's greater than 0. No, G prime is just f of x, okay? And that is greater than 0, so f of x is greater than 0 from -5 to 2. But it's -5 less than or equal to x less than 2. Okay, so that's number 1. Number 2, now I want it to be concave down. So we say G is concave down when G prime, which is what? G double prime, which is F prime, is less than 0. F prime less than 0 means F is decreasing, and that happens on 0 to x to 4. All right? And the region where this overlaps is from what to what? 0 to 2.
Isn't it also decreasing?
Yeah,
from
no,
negative?
Oh, -5 to -3.
Could you do like,
Do
would you
intervals.
use?
No.
We do intervals thing if you want.
And so what is it? -5
And
to -3. So now we haven't given the answer yet.
You do less
So-
than 50 or just less than?
For increase, decrease, just less than.
But for part B, you said that -5 is less than or equal to x, which is less than
Right,
2.
because it's definitely positive at -5.
But we don't know.
But no, we know at 2 it's 0, it's not positive. Concave down and increasing on 0 to 2 and -5 to -3. You can do interval notation as well. C. All right. C, the function h is defined by this. Find h prime of 3. I'm going to give you 3 minutes to do this part. On your mark, get set, go. Okay, so h prime of 3, look at what I did here. 5 times 3, -2, minus 9 times 5. It's chain rule and quotient rule in one. And then when you get to here, look, when you get to here, you can, to do some mental math, from each of these terms, you can take out a 5 and a 3 from each of the terms. So from the first one, you're left with -2. And then if you take out a 5 and a 3, it's -3. And then if you take a 5 and a 3,
But didn't you do it backwards?
no,
Because she started with
-1/3.
Wait, isn't it G prime of 3? G prime of 3 is just F of 3? And F of 3 is 0?
Which is 5x. I did it backwards. Oh, but it's addition.
Just subtraction.
Oh, wait, hold on. Wait,
It's just be.
And D asks us to find the slope of the line tangent to the graph of P at the point where x equals -1. So basically, we just want P prime at 1, right? So P prime of x is f prime of x squared minus x times the derivative of the inside, 2x minus 1. 1 point for that. P prime of -1 is f prime of 1 plus 1, 2 times -3, and that f prime of 2 is at x equals 2, 1, 2. What is the slope? It's -2 times -3, +6. That's all you want. Yep.
Totally unrelated, but it's one of the things that, like, when are they ever going to give us an FRQ where instead of revolving around the x-axis, you have to revolve around the y-axis? And I forgot how you put that in the calculator, because you can't, like, do the y function, if you know what I'm saying. Hopefully we'll find a problem where that happens, but I want to see how we do that on the calculator.